pyramids, seen in the foreground of the model, can be constructed of concrete, steel, or wood, and can be effectively used as both underwater and beach obstacles. They are most useful when beach bottoms are hard, steep, or rocky. Concrete is the best for solid pyramids, and steel the most effective for skeletal pyramids. Wooden pyramids are not durable in surf and should be used in protected waters only. Solid concrete pyramids may vary in size, but whatever the size, they should be reinforced with steel to make them more difficult to demolish. And lifting eyes should protrude from the top of the obstacles to make them easier to move. Often the top of solid pyramids are armed with sharpened steel stakes, which tear holes in the bottom of landing craft. These pyramids are sometimes called horned scullies. Obstacles are used according to the needs of a particular beach. Pyramids may be employed in groups or placed at intervals, in which case they should be close enough to prevent landing craft from freeing themselves, and as in the case with other obstacles, they should be placed in depth. Skeletal pyramids or tetrahedrons can be made of structural steel members bolted or welded together. They are the strongest and most efficient type. Tetrahedrons may also be constructed of concrete. This obstacle is difficult to construct. Thus, it has the lowest priority of the skeletal pyramids. Concrete tetrahedrons are usually employed as landing craft obstacles. Steel tetrahedrons, because of greater strength, are best suited for anti-tank and anti-vehicular obstacles. However, they can be used within the tidal zone against landing craft and amphibious vehicles. Mines attached to these concrete obstacles provide an extra defense measure. The hedgehog, another obstacle used in the tidal zone. It is made of structural steel, railroad rails, steel tubes, or logs. When used in the tidal zone, hedgehogs should be moved frequently, or they will sink into the sand. However, the lower legs can be fitted with anti-tilt pads or tied to anti-scour pads to retard this sinking action. Because of its spider shape, it is effective even when displaced from its original position in the water or on land. Whether partially covered by the tide or not, tidal zone obstacles, like all beach obstacles, set up the enemy for the kill. But should the invader penetrate offshore and tidal zone obstacles, he must then assault our formidable barrier of shore obstacles. Because these obstacles are not subject to surf action, they will generally remain effective longer than offshore and tidal zone obstacles. Some types of shore obstacles are made of concrete. These include concrete walls, pyramids, eggs, cylinders, cubes, dragon's teeth, and coffins. Other shore obstacles are made of steel, such as these steel ramps of curved rail or pipe. They are used mostly on the beach as an anti-tank obstacle. However, it makes an effective landing craft obstacle when used for that purpose. Another type of steel obstacle is the sheet steel piling wall. These can be used in single rows or in depth. Sheet steel piling makes an excellent anti-tank obstacle. Tanks can also be stopped by anti-tank ditches. There are three main types: triangular, side hill cut, and trapezoidal. The triangular anti-tank ditch is a steep ramp ending in a vertical wall at the deep end. It is approximately 15 feet across, 5 feet deep, and forces the tank to land at a steep angle so that it cannot continue forward but must back out. When stopped or slowed down by this obstacle, the tank is vulnerable to anti-tank fire. The side hill cut should be from 15 to 20 feet across and consists of a level approach to a vertical wall about 5 feet high. The earth removed is left in front of the cut, forming an additional obstacle. This obstacle performs the same mission as the triangular ditch. The most effective anti-tank ditch is the trapezoidal.